When I became president of the Rockefeller Foundation in 1998, I inherited many things. And one of those was the history of the Green Revolution. Because when Henry Wallace went back from Mexico to the United States in 1942 after his visit, he went to see Raymond Fosdick, the president of the Rockefeller Foundation, and persuaded him to get involved in helping Mexico achieve food security. And those early years were funded by the Rockefeller Foundation. And then, of course, later, Rockefeller and the Ford Foundation came together to create CIMMYT. And so there's an extra reason why I'm so delighted to be here. We're very short of time, and so I'm going to speak rather fast and go through all of this rather quickly. Assuming I can get the plonker to work. Maybe I got it around the wrong way. The Green Revolution was one of the great technological successes of the 20th century. It increased yields, it increased production, and the real price of staple foods came down. You can see here this increase in yields of wheat in India, Mexico, and Pakistan going on at least until 2010. You can also see this drop in real food prices that began in the 1970s and continued right until very recently, a continuing drop in real food prices. And all of this, of course, meant that people were being fed, and in particular, that poorer people were being fed. But there were teething problems. One of the first was that great big harvest in India that Norm Borlaug brought about when he brought the seed over. It was more than anybody had anticipated. There weren't enough bullock carts to haul the wheat to the threshing floors. And in some towns, they actually had to close the schools so they could store the grain. It makes the point that's worth remembering now that when you have a technological advance, you need the infrastructure and the markets to go along with it. Never forget that. And there were limitations. It focused too much on ideal environments. There was a heavy reliance on synthetic pesticides and fertilizers. Not all the poor benefited, and in general, it passed Africa by. First of all, there was this very heavy use of insecticides on the rice in Southeast Asia. I remember I was working in Borneo in 1961, and I went up to Iri in 62, and I was appalled to see the way in which insecticides were being used on the rice fields. Cans of chlordine were being put in the water channels from field to field. And what then happened was these massive outbreaks of brown planthoppers, $300 million worth of damage up to the 1970s in Indonesia. And of course, it was then discovered that the pesticides were killing the natural enemies of the brown planthopper, killing the wolf spiders. What is regrettable is that this is all coming back again now. We're getting outbreaks of planthoppers and leafhoppers because we're overspraying with insecticides. We have got to relearn the lessons of the 1970s again. Fertilizers were the basis of the Green Revolution, but what we've seen since then is an increasing reliance on synthetic fertilizers, in many cases grossly overusing them. In China, for example, there's widespread 30 to 60% overuse of fertilizers. You can see the particular areas in black there with very heavy nitrogen inputs to the main river catchments. Not all of that due to agricultural nitrogen, but a great deal of it along the way. And a great deal, of course, as you can see in South Asia, in addition to China. And the impact on malnourishment has not been even. If you look at South Asia there, you can see that the numbers malnourished has increased because of population increase, but the proportion of the population malnourished has gone down dramatically from 34% to 22%. But in sub-Saharan Africa, the numbers of malnourished have gone up, and so has the proportion of the population that's malnourished. So where are we today? If you look at the Global Hunger Index, which is a combination of the number of people who are hungry and the number of children who are malnourished, they're stunted, and the number of children under the age of 5 who die, if you look at that mixture of measures, which IFPRI came up with, you can see the extremely alarming levels of hunger in Africa, and to some extent still true in India. We live in a world of global crises, not just food security, but financial crises, water, climate change, environmental services, energy, civil strife. Many of these chronic crises are getting worse, and all of them are increasingly interconnected. It's very difficult to talk about food security without talking about all the other crises that are going on. But that's what I'm going to do. There are 3 challenges to food security at the moment. The first is rising food prices and rising fluctuation of food prices. And as we all know, that affects the poor worst of all, because the poor spend such a high proportion of their income on food. Secondly, there's about 1 billion people who are chronically hungry, give or take a few million. And the most shocking of statistics is that 180 million children under the age of 5 are malnourished. That means they're under height for their age. It means they will grow up stunted. It means they may become blind, they may die, and at best may have stunted development and therefore not do well in school. And in Africa, 40% of all the children under the age of 5 are malnourished. 40% out of the whole continent of Africa. And thirdly, we've got the challenge ahead. We have to feed the world by 2050. That means we've got to increase food production by 70 to 100%, something of that order. And there are several challenges we have to meet. One is demand, population growth, changing diets, biofuel demand, supply, prices, climate change, land and water scarcity. You could teach a whole master's degree based on that single slide alone, but you're only going to get 2 minutes. First of all, the world population looks as though it's going to level off, probably around 9-10 billion people. But the population growth in Africa is still roaring ahead. No sign of it leveling off, particularly in East Africa and West Africa. Most people think that it's population growth that's the biggest obstacle to feeding the world. I don't actually think it is. I think if you simply look at food production, the growth of food production and the growth of population, they more or less are even. In other words, if it was just more people alone, we could feed the world. But the problem is that many countries in the world are increasing their per capita incomes. Countries like China and India and Korea and Mexico and Nigeria, Brazil, and all those countries are switching towards a more Western-style diet. They're beginning to consume more livestock products, and milk and cheese, and yogurt and butter, and poultry meat, and lamb and beef and pig meat. On the right there, the green graph is the amount of pork and pig meat that's consumed in the world, and half of that is consumed in China. Half of all the pork and pig meat in the world is consumed in China. That's one of the reasons why China is about to buy Smithfield Company in the United States, which is the largest producer and processor of pork in North America. And of course, for every kilo of meat you produce, you need 7 or 8 kilos of grain. On the supply side, and I'm jumping here just to get through in time, there is the problem of climate change. The climate is changing. Everywhere you go in Africa, if you meet Africans in a village and you say to them, is the climate changing? They say, yes, of course it is. And you ask them how it's changing, they'll tell you how it's changing. And you ask them, are they doing anything about it? And they say, yes, they're doing things about it. There may be skeptics around the world, but there aren't any skeptics in the villages in Africa. They're coping with stress already. The length of the growing period, for example, in the Sahel, is very short anyway, and it's declining. I was in northern Ghana last year, the year before last actually, and the rains had come a month late and they'd finished a month early. There simply wasn't the time to grow the kind of crops they want. And in addition to these stresses, of which there are many, including, of course, high temperature, rising sea levels, there's also the shocks that come, the extreme events, the floods, the droughts, the cyclones, the great heat wave in Russia in 2010 when 30% of the grain was lost, and in Pakistan the worst floods in 80 years. Both of them caused by the same weather phenomenon at that time. And there is evidence that these extreme events are increasing in either frequency or size, or both. And finally, there's the problem of land and water scarcity, the physical scarcity of good quality land. Because in both cases of land and water, there's overuse, there's degradation, pollution, and sterilization. So, what do we have to do? This is the slogan. This is the slogan which I think Norman Borlaug would agree with. We must produce more with less. More food, more nutritious foods, higher farm incomes, on the same amount of land or water or less. That's what we have to do. Because we've got to intensify production. We've got to get yields up. The yields in Africa, sub-Saharan Africa, are little more on average than a ton per hectare for the major grains. For example, for maize, little more than a ton per hectare. It's more or less flat. It's what we used to get in Britain at the time of the Roman Empire. The yields in Africa have got to start moving up in the way that they are in India and China. And there are problems with the yields. For example, with wheat. At the global level, you can begin to see the bottom line there looks like there's a bit of a leveling off of yields. But if you look in particular at the yields in France and Germany and the United Kingdom, the yields are certainly leveling off and they're becoming much more fluctuating. There are many factors involved in this. It's not just a genetic phenomenon. But that's one of the problems that we have to cope with. But most important, we have to make sure that the intensification, this getting more with less, is sustainable. We have to use inputs like pesticides and fertilizers more efficiently and more prudently. We have to minimize the emission of greenhouse gases from agriculture. Carbon dioxide, methane, nitrous oxide. We have to increase natural capital. That means, for example, building up the water retaining capacity of soils, building up soil structure, building up the biota in the soil. building up natural enemies of pests and diseases. We have to reduce environmental impact, and we have to strengthen resilience, the capacity of plants and fields and whole farms to withstand the stresses, to withstand the extreme events, and to recover from floods and droughts. All of that is what we call sustainable intensification. And that's the other slogan, if you like, for the future. More with less, but sustainably. It's a tall order. It's a challenge of an order of magnitude greater than that at the time of the Green Revolution. Let's give you an example. Precision farming. You can map, farmers in the developed countries map their fields to get the amount of fertilizer that is needed. For example, to find out what the levels of nitrogen and phosphorus and potassium are in the fields. And then they feed that into a computer on a tractor. And as the tractor moves around the field, they use GPS systems which say, okay, here put some potassium in the soil, here put some nitrogen in the soil, and so on. You're targeting the use of nitrogen instead of just spreading it all around the ground. It's the same principle in developing countries. This is microdosing in Niger on maize. What you do there is you take the fertilizer and you put it in the cap of a Pepsi Cola or a Coca-Cola or any cola you like. It doesn't matter. You put it in the cap and you put it in the hole before you plant the seed. This, of course, doesn't quite work with wheat, but it's still possible to target wheat inputs. Now, this is an experiment I came across that was carried out recently in Iran. What they did was to have a number of different fields of wheat, and they tried different management of those fields, and then worked out how much greenhouse gases were emitted. The greenhouse gases from the energy, from producing, for example, the fertilizers, and from applying the fertilizers. And the left-hand column there is the common practice. About 70% of the farmers there in Gorgan in Iran had a practice that resulted in over 1,000 kilogram equivalent of carbon dioxide per hectare. One of the other experiments was high inputs of fertilizer, high inputs of machinery, and they were getting 1,600 kilograms per hectare. And then they had a best management system in which they were optimizing the use of fertilizers and machinery. I can't go into it in detail, I don't need to. I just want to make the point that then they were only getting 900 kilos of carbon dioxide per hectare. And in that last best management trial, they were getting 33% greater yield than in the common practice that the farmers were adopting. So that's an example of what we mean by sustainable intensification. Getting higher yields, but doing it in a way that reduces, for example, greenhouse gases. The challenge is that if you want sustainable intensification, it's complicated by the fact that you're focusing on multiple benefits, which means inevitably you have to engage with multiple partners. You have to engage with CG institutes, with IARs, you have to engage with the non-profit and with the profit community. You can't just do it alone in one institute. You've got to use different institutes together. You've got to use multiple approaches, and I'll come to that in a minute, and you've got to use multiple scales. We don't really yet know how to do this. If you want multiple benefits, what's the best way to do it? Do you start with one benefit and add the others? Do you try and get all the benefits at once? We don't know yet how you're going to do this, but that's what you have to do for the future. I said there are three kinds of approach. One is agroecology, Another is genetics, another is socioeconomic. So we're talking about, first of all, sustainable ecological intensification. Using ecological principles and practices to create intensification that's sustainable. Agroforestry, IPM, conservation farming, organic farming, all with a greater emphasis on biodiversity. Example of agroforestry and wheat. In France on the left, in Kazakhstan on the right, in which you've got mutual benefits. The trees grow better in these circumstances, they provide windbreaks, and they bring up nutrients from much deeper in the ground for the wheat that's growing in between. No-till wheat production, where instead of ploughing the soil, you leave the stalks of wheat and the leaves of wheat on the ground so that they rot down into the soil. And then you sow the next crop. The left-hand side is beans. You're sowing them in the ground that's covered with the remains of the previous wheat crop. And that way, you improve the soil structure, you increase soil moisture, and you often get bigger yields with much lower emissions of greenhouse gases. And of course, the big challenge here are rice wheat systems that grow all the way across Asia. This is an enormously complicated research challenge here. The traditional rice wheat systems chug along, producing reasonable amounts of wheat and rice in a very traditional fashion, if you like. But once you try and intensify these to produce much higher yields of wheat and rice, it gets very difficult, because you don't really have natural mutualism between the two crops. In a way, you've got antagonism between them, because you've got this switch from aerobic to anaerobic to aerobic and so on, which is extremely difficult to manage. And it changes everything. It changes the weeds, it changes the pests, it changes the diseases, it changes the soil structure and so on. To begin with, they thought that the answer was no-till production, as I described just now. But then people said, oh, if you do that, then the stem borers of the rice will go on from one generation to the next. We mustn't do it. And so there was a big campaign against no-till. And then it was discovered that, in fact, under no-till, the natural enemies of the stem borers flourished, and it worked. So now no-till is part of the intensified systems. The other challenge is to get the wheat in after the rice very fast. And that has been answered by special machinery, and in particular by the Pantnagar drill. It's a very interesting example of sustainable intensification, which people have been working on for 20 years, because it demonstrates just how difficult it is to manipulate an agricultural system to be intense and sustainable. Now, the problem with those ecological approaches is that they often require a lot of skill, they often require a lot of labor, and there's often a yield penalty. I'm an ecologist, but I admit that ecological approaches are not the only approach, and are often not the best approach. That may lie more in sustainable genetic intensification, bringing traits together in individual plants. Here's an example from Rothamsted in Britain of the kind of challenges they're trying to tackle: increasing wheat productivity to yield 20 tons per hectare in 20 years, focusing in particular on maximizing yield potential, protecting the yield potential, and importantly, on improving the utilization of soil resources by growing plants. This is the kind of approach that's, of course, also being followed by the CPR program on wheat in a much bigger way. A lot of this is helped by the fact that we are beginning to understand the genetic makeup of the wheats, in particular of the bread wheats. This is some work carried out by British, American, and German scientists, in which they've looked at the genomes of bread wheat, the ABDs down there, the three original genomes that come together, and in the middle brachypodium, the 5 genomes there, using this analysis to begin to understand what the genes are doing and where the genes are, and in particular where the genes are lost. Quite a lot of the genes earlier on in the evolution of wheat, in the diploid and quadruploid forms of wheat, have got lost. But this is extremely complicated, as you all know, simply because bread wheat is a hexaploid, to understand the genetics, but we're beginning to do so. 95,000 genes out there is enough for all of you to do some interesting work, it seems to me. And we're beginning to, in particular, discover what genes there are that are effective, for example, in controlling pests and diseases, or in drought tolerance. We heard a lot about rust this morning. The rusts, I'm afraid, haven't gone away. They're still there with us. The stem rust, the yellow rust, the brown, the stem rust of the green, and in particular the UG99, which is the most recent version of the stem rust. And of course, the challenge here is not just to produce wheat varieties that are resistant to rust, but are resistant to the new rust strains that the rust will throw up. We've somehow got to get a form of resistance that is resistant to the range of varieties that rust will evolve into the future. And that's a huge task. And then there's drought tolerance. One of the most interesting developments recently in maize has been the use of the so-called chaperone genes, which allow plants to recover from drought. Because when drought occurs, the RNA molecules misfold, the protein molecules misfold in the cell. When they misfold, when many of them misfold, of course, the cell dies, and that's why plants die under drought. And what the chaperone gene does is to produce new molecules that will cause the RNA molecules to refold properly. And so as a result, the plants will recover. And the first commercial varieties of these, Drought Guard, with this gene, this GM gene in it, were released in 2013 on a relatively small scale. I don't know whether anybody is working on these in wheat. I suspect they are, but I think we're going to hear more about the role of chaperone genes into the future. And the ultimate prize, of course, is to get cereals like wheat to fix their own nitrogen. And the breakthrough here has been the discovery, if you like, that the earliest plants have a signaling pathway, evolved a signaling pathway, in which they deal with bacteria and other microorganisms, which allows the development of mycorrhiza to occur. 45 million years ago that happened. And then much more recently, the legumes have adapted that signaling system to produce nitrogen-fixing nodules. So the same genetically based signaling system produces mycorrhiza on the one hand and nodules with bacteria that fix nitrogen. It's out of that kind of understanding that eventually I think we're going to get wheat and rice and maize that fix their own nitrogen. Not just yet, but I would have thought within the next 20 years. And we also need socio-economic intensification, sustainable socio-economic intensification, particularly in developing countries, particularly in Africa. The key to producing more food in Africa is to link farmers, and don't forget 70% of all the farmers in Africa are smallholders with less than 2 hectares, to link them to markets. That's the key to success, to make sure that they can get the inputs they need. Little agro dealers, ladies here that sell small amounts of seed and fertilizer that are within walking distance of the average farmer. And on the right, seed companies that produce seed that are certified. In other words, when you get the seed, it does what it says on the packet. That's the key to input markets. And then we also need output markets. And the only way forward there is for farmers to come together in some kind of association so they can get a better deal, so they can get better prices for their crops. And the big question is, which of these kinds of farmer association are sustainable? In what circumstances, in what countries? And of course, what happens at the village level has to be duplicated, as it were, at the national level. This is the Ethiopian commodity exchange, where dealers come to buy and sell. Dealers representing farmers come to buy and sell food produce. Mostly at the moment it's coffee, but soon it'll be maize. You can see them there in the middle of the dealing going on, and you can see the ticker tapes up on the top. What is remarkable is that when you look at those screens on the top, you can see the prices at which the crops are being traded in the floor, on the floor, and also the prices in Chicago at the same time. So you're beginning in this way to link farmers and their expectations to those at the global level. And finally, we have to work at multiple scales. In some ways, it's easy to produce sustainable intensification that works on an individual farm or even in an individual village. The big challenge is, how do you multiply that up so that it works at a much greater level? For example, at the level of the landscape. How do you start to produce sustainable landscapes? I don't know quite what a sustainable landscape is, but I'm going to give you just 2 examples to finish. I took these photographs last weekend. They're on the Sussex Downs in the south of England, close to the sea, chalk downland. You can see the fields on the left there. And in that field there, when you excavate, you can see on the right the remains of the little houses, little huts of farmers over 3,000 years ago. They were growing wheat then, over 3,000 years ago. In fact, they were growing wheat probably, we don't know, but we're pretty sure they were growing wheat there maybe 4,000 or 5,000 years ago. And you can see in the bottom, they're still growing wheat. The soil is beautiful because it's so easy to work. The original farmers could do it with the antlers of a deer. They could scrape the soil and put the seed in. So, is that sustainable agriculture? And if you stand on the downs and look down, which I did last Saturday, my farmhouse is up towards the back there. Half of those green fields are pastures with sheep and lambs. We're well into lambing now. And the other half are winter wheat. This has been a fertile part of the country for thousands of years. At the time of the Roman Empire, 2,000 years ago, we, I mean not me particularly, but we in general, were producing food for the Roman navy along the coast of Pevensey. You can see the tracks and the roads that they took the produce there. So that is another, it seems to me, if we've been growing winter wheat there for at least 2,000 years, that's another sustainable landscape, or is it? And I want to stop there and leave you with that final question about sustainable intensification. What do we mean by a sustainable landscape? Out here, next to where we are, is that a sustainable wheat landscape? I don't know. I want to thank you. I'd like to point out that there's a panel report produced by the Montpellier panel, which I chair and funded by Bill and Melinda Gates, on sustainable intensification. Some of you have got copies already. Others, if you want them, you have to download them from Agriculture for Impact, the website at the top. And a lot of this is in my book, including a history of the Green Revolution, which some of you may find interesting, in 1 Billion Hungry Can We Feed the World. And I just also finally want to say is there is a website linked to the book called canwefeedtheworld.org, and that updates the book every week. So it's a living book. That doesn't cost you anything. The book does. Thank you.